this is what rounds them up. And then you get them up going really fast, and then you split them off into that wave state, and you have them go in opposite directions. And then they try to hit each other. Like one of them like nine. You are just transporting the hand capsule atlas. Here is a representation of what happens with the particles. It's a side view. So you can see that an electron is much banded because it's not much massive, left, while a proton, much more massive and opposite electric charge, is banded right. So this is done in the track detector, which is in the middle. How do we see these traces? It's also a good question. This is an animation showing you one of the systems to see the particles. If you go in the track detector, the inner part is made of thousands of tiny electronic modules. One of them is exposed here. We can have a look at after. And here we have a silicon layer. Let's remove the silicon. And under the silicon layer, you've got tiny, tiny metal balls. Each ball corresponds to one pixel, one measurement that something went through this. That's roughly what it is. So let's go inside the silicon layer up to the molecular level. What happens? A particle gets through this silicon layer. And in fact, it rips off electrons from the atoms of silicon. And all these electrons will be then attracted by these metal balls, tiny at our level, huge at the molecular level, as you can imagine, and it will generate an electric signal. Excuse me. They will generate an electric signal which can be sent to the electronics. What does it give us as information? Something went through this. On its own, it doesn't give you much. But if you pile up multiple of these modules, you have 2D and then 3D, you can have a 3D curve by having a series of dots. And then we need computers to link these dots and say these belong to the same curve, so to the same particle. It's like the game everybody is playing. You have a cloud of dots, and if you join them in a certain order, you see a dot, half, whatever. It's the same, except a bit higher level. It's about the same idea. So curves, very important. We can nearly identify the particles. And then we have two layers which are called the calorimeters. The calorimeters are measuring the energy of the particles. And for that they will absorb the particles. Why two? We have the first calorimeter, which is called the electromagnetic calorimeter. It will trap a certain family of particles.